Can everyone see my screen?
Yes.
Okay. Good afternoon, everyone. I'm going to present the paper investigating the use of multiple languages for crisp and fuzzy speaker identification. It was produced by Thales Aguiar de Lima, me, and Márjory da Costa-Abreu. The main problem we approach in this paper is the speaker identification, which consists on making the computer able to identify the owner of a given voice recording. The general procedure of these systems is when someone speaks something, the speech is recorded and further it is digitalized. This digitalized version is given as input to a mathematical model, which is responsible for identifying the best fit from a given speaker database. However, there are several sources that can impact on performance of these systems. And one of them is the health condition of the speaker, the age of the speaker, and also some noises like background noise, which can be car sounds on the background, or even someone speaking over the main speaker, and also problems coming from the recording device, such as clicks and hiss noises. However, in this paper, we want to investigate how the languages can impact on those systems. For that, therefore, we want to answer the question, is the model still able to reliably identify the owner of a given voice if I add more languages to the data? For that, we adopted three main languages, which are English, Brazilian Portuguese, and traditional Chinese or Mandarin. And we used those languages because they do not share any common ancestor as languages. So it removes the biases that could come from using similar languages such as Brazilian Portuguese and Spanish, or English and German. For creating such a database, we used three main data sets, which are the DARPAtimity, the LAPS Benchmark 16K, and the AI Shell 1, respectively in English, Brazilian Portuguese, and Chinese. However, since we're dealing with different data sets, we have a different amount of data for each language. Therefore, there could be influence on the results given the amount of data, such as a language being very distinguishable from another one, not because the language, but because of how much data is available for training or testing. Therefore, we applied a reduction. We reduced the number of speakers from both English and Chinese to have a more similar amount of speakers as there is in Brazilian Portuguese dataset, and also applied a roll-it undersampling for the Brazilian Portuguese and the Chinese data, so we could have the same number of samples per speaker as there is in the English data. After applying these pre-processing methods, we end up with the following distribution with respect to the languages. We can see that the dataset, the final dataset, is well distributed with respect to the languages. Meanwhile, the inner circle represents the distribution with respect to the gender. We can see that this is not very well distributed. However, it's not a very concerning attribute since it's not the main problem we are approaching in this paper. After these methods, we proceed to the feature extraction, which consisted of a wideband spectral analysis and the extraction of 13 MFCCs, that is the male frequency septum coefficients. We further excluded the zero coefficient since in the Brazilian Portuguese, this coefficient was concentrating most of the energy of the signal, and therefore it was causing the results to be very biased towards this language. That is, the Brazilian Portuguese speakers were very distinguishable from both Chinese and English, not because the language itself, but because of the recording procedure adopting during the collection phase of this dataset. And also after that, we applied exceptional mean normalization that reduces the channel variation of such signals. And since we are dealing with distinct data sets and each of them may have been recorded with different recording devices. Finally, we also extracted the first and second derivatives of the 13 MFCCs, and which represents the speed and direction of variation of each section. Therefore, we had a 39-dimensional feature vector for each model applied in the experimental setup. In the experimental setup stage, we adopted 4 main models: the support vector machine, the k-nearest neighbors, the fuzzy k-nearest neighbors, and the fuzzy c-means. The fuzzy c-means, the FCM, it represents a more distinct approach with respect to the older models adopted in this paper. Meanwhile, the KNN and the FKNN, they is a face-to-face comparison between a fuzzy and a crisp model. And finally, the SVM has a very large history in the literature for both speaker identification and verification. Also, we applied a threefold cross-validation for the experiments, which was stratified with respect to the languages. And we divided the experiments on single, dual, and triple language setups, which enables us to better address the effects of adding more languages to the system. So on the after the first experiment, the single language setup is applied on Brazilian Portuguese, and we then add the English data and the Chinese data. As you can see, each fold, since we're stratifying the data, we are assured that each fold has the same amount of speakers from each language. However, here we only apply the dual and triple language setups on the model, the best performant on the Brazilian Portuguese data. With respect to the results, we find that the fuzzy means had the worst performance of the other models between the models we selected. Meanwhile, the fuzz k-nearest neighbors outperforms the crisp version, not by a large margin, about 1.4% accuracy higher than the k-nearest neighbors. However, it's still a better performance than its crisp version. And finally, we, as expected, the support vector machine achieves the highest accuracy of all, and it is further carried to the dual and triple language setups. As on the results, we find that on the language confusion matrices, that the dual language setup using the SVM, we can see that the Brazilian Portuguese speakers are very distinguishable from the English data. Meanwhile, the English speakers are yet confused by Brazilian Portuguese speakers. And this behavior is yet carried to the triple language setup, where we can see that the Brazilian Portuguese speakers are still very distinguishable now from both English and Chinese data. Meanwhile, the English and Chinese speakers are more frequently mistaken one by the other. As an overview of the results, we can see that the SVM achieved about 87% accuracy on the single language setup. However, when we added the English data, we observed a slightly reduction on the accuracy, and another one when we add the Chinese data. While investigating these, the first aspect was the gender distribution, as it is usually easier to identify it's usually there is a difference between identifying the female and male speakers. So when we're looking at the confusions between genders, we find that there was not it was not by difference by a large margin from what was expected given the distribution we had. And then we realized that in this method, when we add more languages, we are also adding more classes to the problem, which can be harmful to classification problems. Therefore, we create another round of experiments, which consists on creating smaller multilingual datasets, which contain speakers from all the languages. That is, they contain speakers from the Brazilian Portuguese, the English, and the Chinese data. However, this time, the number of speakers on this dataset is limited to the amount of speakers that has in the single language setup. There is the Brazilian Portuguese. And after running those experiments, we find that there was actually not a significant difference between these two, the smaller multilingual dataset and the single language dataset. Therefore, the reductions on accuracy are more likely to be related to the additional classes that the additional data implies, rather than the languages itself. So, as final remarks, we want to reassure that adding language does decrease the accuracy of those systems. However, it's more likely they are due to the additional classes or speakers that comes with the additional data. Also, using the methodology we adopted on this paper, that is the SVM in combination with the MFCCs, you can create a robust multilingual, a robust speaker identification system on multilingual environments. With respect to the fuzzy classifiers, we see that overall they can provide better results than the crisp versions, and these results, they possibly come from the better flexibility to deal with those approaches. However, this flexibility also may comes with the cost of adding more parameters to the model and possibly creating a slower version of this model. Finally, we also find that the Chinese speaker confusions hold 79% of gender mistakes. That is, if given given an input voice to the system and the output of the system is of a opposite gender, and there is a 79% chance that this is coming from a Chinese speaker. That's it. Thank you, everyone, and I'm now open for questions.
Okay, thank you, Thales. Any question? I have one. You show results of accuracy, and what happens with the result of time? Do you have any comparison of time between?
Yes, the time comparison, if I can recall now, I think it's on the paper. However, I did not show it in the presentation due to time and not the amount of results also. However, the time, we can see that the fuzzy models, they are very slower than its crisp versions. However, it's a bit complicated to make this comparison, since both the KNN and SVM, they are implementations from the sklearn library from Python. Meanwhile, the fuzzy models, they had to be implemented and therefore there is a margin of optimization between those two.
But we are talking about seconds, minutes, hours, days.
It was on picoseconds, if I'm not mistaken. It was not really large metric used, but if you add more and more data, it is possibly become unable to run those experiments.
Okay. Any other question?
I think there is a question in the chat. Have you, from Marie Burton, have you find a link with the age of the person? I can't address that since there was no age label on any of these data sets. I mean, on most of them, there was the age labeling on the Darpatimity data set. However, on Brazilian, Portuguese, and Chinese data, I did not have this information. So I could not address the relation between the age of the person.
Okay. Okay. Good presentation. Thank you, Thales.
Thank you.